Hello everyone, welcome back to my channel InfoSec Lab, and today we are going to talk about AWS S3 services and some of its common security features. We also go over some common attacks on AWS S3 service and how to mitigate those attacks or how to defend against those attacks. For those of you who don't know, this video is a continuation of TryHackMe's attacking and defending AWS services learning path. Alright, so without further ado, let's get started. Introduction: S3, a versatile service. AWS S3 helped set AWS apart as a powerhouse in cloud computing. Being able to arbitrarily scale data storage and use it in interactions across AWS services has meant that S3 is deeply entangled in how almost all organizations use AWS. However, that power doesn't come without its own weaknesses. S3 is one of the most commonly abused services in AWS. During this room, you will learn the key capabilities and attack surfaces of S3. Learning objectives: students will learn the basics of S3 concepts, such as the buckets, objects, ACLs, buckets policy. Students will learn about common security issues related to public S3 buckets and how S3 buckets are used in automation. Finally, students will use this knowledge to attack S3 buckets, exfiltrating data, and using the data to further compromise an organization. Okay, let's get started. Accessing the cloud environment. So we all have our own credentials, and this is the instructions on how to configure AWS account on your TryHackMe account. So I'm gonna skip this one. S3 service overview. Terms and concept, bucket and object. Before we start off attacking S3 or other cloud services, it is important to understand that you are not attacking a typical server or workstation for an organization. The analogies to system would be incomplete, inaccurate, as S3 is a custom developed service offered by AWS. Specifically, S3 serves as an object or file storage system. Customers can replace arbitrary files as large as 5 terabytes with an S3 bucket. Directory structure. While S3 bucket is a file storage system, it has a flash file structure. Unlike most other file storage systems, this means that standard Unix or POSIX behavior associated with file directories is not inherently applied inside S3 buckets. However, as noted by AWS, the // character can be used to organize objects into a hierarchical structure using folders. Objects can be inside folders nested inside other folders, but buckets cannot be nested inside other buckets. Alright, objects durability. S3 is one of the largest holistic data stores on Earth. Such a large data store needs to have guarantees about how trustworthy it is with regard to maintaining stored data. AWS claims that S3 has a durability of 99.99999, which is 11 nines. This means that AWS only loses 1 out of every 100 billion objects that are stored in S3 on average, although with over 100 trillion object storage globally, S3 still loses roughly 1,000 objects per year. Access control. S3 object permissions also work differently than standard Unix or POSIX or NTFS-based file system. Permissions to S3 bucket object consist of a variety of API methods, which can be restricted using IAM and/or resource-based policy. You can learn more about IAM and resource-based policy in the AWS basic concept group. The critical permissions associated with the S3 buckets include S3 get object and S3 put object. These are equivalent to read and write permissions, respectively. Such permissions can be applied to individual objects, a folder, or an entire bucket. Other controls. In relation to S3, there are 2 additional controls that affect S3 buckets objects. The first is a concept known as object versioning. If enabled, Uploading a new version of the file will not override the original file, but rather preserve a new version of the file for every version uploaded. This can become costly over time, but may be an important security control when using S3 to store automation script and other source code. In such situations, versioning serves as a type of source code pinning, and may prevent an attacker from replacing the source code depending on the attacker's permission. The second is a concept we all are familiar with: encryption. While we have a separate room that covers AWS encryption in depth, it is important to note that S3 is commonly used with default encryption. This means, frequently, an attacker would need permissions to use the relevant encryption key in order to read a plaintext object stored in S3 buckets. In most configurations, this won't be a real hurdle for attackers, but it is important to note that S3 buckets are commonly encrypted by default. Access control lists, or ACLs. ACLs are the original method for controlling access to S3 buckets. In fact, S3 ACLs predate the AWS IAM service altogether. A bucket automatically generates an ACL for the bucket on creation that provides the resource owner with full permissions against the bucket. However, ACLs can be added to expand access to other AWS IAM principles, including AWS services, third parties with AWS accounts, and even unauthenticated users simply browsing the internet. An ACL might look similar to the following. So this is a XML file. Okay, this is ID of the owner, display name, and this is the access control list, grant permissions. Okay. In this example, the ACL grants full control access to canonical user of ID 79854, which is this one. And the full control permission is right here, it's specified right here. Okay. A canonical user ID is an AWS internal reference ID for any AWS IAM principle. In this case, the canonical ID translates into a root account user with the display name WA. Okay, this one right here. You can find your canonical ID using your canonical user ID using these instructions from AWS. As you can see, S3 ACLs are not very human readable friendly. AWS improved on ACLs with a bucket policy, and since November 2021, AWS has recommended that S3 buckets only disable ACLs. However, the majority of S3 buckets likely predate the ability to disable S3 ACLs and are, therefore, likely to be still enabled. S3 ACLs also creates one of the lesser known security risks in relation to AWS IAM. While any authenticated AWS user is not an AWS IAM principal, it is a supported group that can be provisioned access to S3 buckets. In fact, companies such as Shopify have been directly impacted by abuse of this excessive permission. When configured, anyone with valid AWS credentials can access the associated resources. Let's take a look at the bucket policies. Bucket policies. Over time, AWS developed and released the bucket policies capability. Bucket policies are similar to ACLs. They allow you to control access to S3 buckets, but they follow more human-readable syntax. For this reason, bucket policies are preferred. Notably, S3 bucket policies are the first instance of what became known as the resource-based policies, whereas identity-based permissions in AWS are tied to an IAM principle. Resource-based policies permit direct access to the attached resource. This means that if a policy allows global read and write access, then you would not need AWS credentials to view data in the bucket or even to add the files to the bucket. Such a policy takes the following form. So SID statement ID effect allows all the principals on the AWS resources. The action is to read the bucket and then to modify the bucket. The resource is name is my bucket, and then whatever objects inside this my bucket. So my bucket here is the name of the S3 bucket. What is the name of the file storage containing where you keep your data in S3? What is it? What characters make bucket policy preferable? It's more human readable syntax. Okay, what is the name of the file storage container where you keep your data in S3? Objects, yes. No. Folder? Huh. What is this name of the file storage container? Bucket. Brr. S3 bucket. CloudFront overview. CloudFront security. CloudFront is the AWS Content Distribution Network CDN offering. We originally introduced CDNs in the AWS Cloud 101 task file. For those who didn't go through the Cloud 101 AWS room, a CDN is a set of servers distributed around the world and designed to intelligently cache customer content to improve end-user experience. This allows websites to confidently scale traffic by offloading the serving of the content that is static or unlikely to change, in addition to providing latency improvements for end users. CloudFront has a number of capabilities that enhance the security of CloudFront hosted resources. For instance, CloudFront can be used to place geo restrictions on access specific content. CloudFront can also enforce authorizations based on a request signature, so that users must authenticate to view sensitive data hosted by CloudFront. Furthermore, CloudFront can go as far as to encrypt specific data fields, so that only systems with appropriate rights can unencrypt the field level data. CloudFront also integrates with AWS Web Application Firewalls, WAF, and AWS Shield Advanced Distribution Denial Service (DDoS) protections. These capabilities allow standard protections to be applied to CloudFront origins with minimal configurations. CloudFront origin, what is it? CloudFront origins are the resource to be hosted behind the CloudFront. You might use an EC2 instance, which is known as server, as a CloudFront origin, and point to the IP address 10.10.10.10. Similarly, you may store static files in the S3 buckets and serve those clients from CloudFront. While many companies set up dedicated servers and buckets for hosting public content, it is not uncommon to find S3 buckets with mixed uses, hosting public and private content. After all, S3 buckets are a great place to store data of all types. If you are able to find such mixed-use buckets as an origin behind a CloudFront distribution, you may be able to pilfer the bucket for interesting information and or additional access. Why not the only thing that might be served behind the CloudFront? S3 buckets are commonly chosen. Why CloudFront origins? Resource to be hosted behind okay. Moving on to the lab. Identifying misconfigured CloudFront distributions, CloudFront origins and bypassing CloudFront distributions. While, while CloudFront does a fantastic job at catching and serving static content to your users on the internet, there has to be some initial source that content, or what is known as the CloudFront origins. CloudFront origins may point to an EC2 instances, S3 buckets, API gateway endpoints, elastic load balancers, or a variety of other AWS service capabilities. When using CloudFront, AWS expects the customer to restrict access to such origins using resource-based policy, restrictions, or security group rules. When properly restricted, only the CloudFront distribution has permissions to talk to the backend service or resources, and all users must communicate with the CloudFront distribution. Unfortunately, many customers are not allowed to do so. Many customers are not aware or do not properly configure such origins access identity, which is known as OAI. And it is common to find CloudFront origins that can be accessed directly, bypassing presumed security controls implemented with CloudFront and exposing additional opportunities for content discovery. An origin access identity means that only a specific CloudFront resource will be able to access an S3 buckets behind the CloudFront origin. This will be performed by putting the CloudFront OAI or origin access identity in the bucket policy for the S3 bucket, similar to the below. Okay, I don't know what happened to my attack box. It just disconnects. Let's wait for it to reconnect and then we can continue. In the meantime, let's continue with the reading. This policy allows only the CloudFront OAI to perform S3 get object request against the bucket name right here. Here's the action, only the get object. Once this has been configured, users will not be able to directly access the S3 bucket. Okay, how can you find misconfigured CloudFront origins? It can be a bit of guesswork, but once you identify that CloudFront is the host of the content you've identified, then you can attempt to identify the hosted resource. TryHackMe has an entire room dedicated to learning about subdomain enumerations and DNS reconnaissance. If you are unfamiliar with these techniques, then you should go and review that room. Knowing the domain name, we begin by trying to determine the domain by its hosting in our DNS reconnaissance technique. Okay, so this is the room that TryHackMe recommended. Passive reconnaissance. I would highly suggest you do this one because reconnaissance, even though it might sound unimportant, it is really helpful because when doing a pen test, the most important thing is to know the system very well and to gather as much information as possible. With the more information you gather, the better it is, and then for your pen testing work. And who knows, maybe that there may be some helpful information that helps you exploit some critical vulnerabilities. So keep in mind that enumeration is very important. And then in this case, thanks to reconnaissance step, that we know whether a web application is hosted behind a CloudFront or not. Certificate transparency logs. Search.sh is one of many public sources where you can identify certificates for DNS domains that are locked. This commonly allows you to identify many subdomains and other domains associated with the particular domain via SSL or TLS certificates. When we search for bestcloudcompany.org, we find a number of records. It appears that at least one subdomain exists for the bestcloudcompany.org, access.bestcloudcompany.org. Perhaps we can identify the additional best cloud companies resources using this information. Okay, since my virtual machine just restarted, I have to reconfigure my AWS account. So instead of using the attack box, I'll try to use the Cloud Shell on the AWS console. But over here, this one doesn't have anything to do with AWS account yet. So I'm going to use the attack box for now. Analyzing host for certificate transparency log results. We are using the known domain and subdomains. You should perform DNS looking to perform. Okay, first let's step one step back. So we know the domain name is bestcloudcompany.org, right? Let's try to look this one up on the website. Search.sh. I'm gonna put it right here. Search. Okay, as we've been told that this website has a subdomain of assets, and then we could confirm right here the assets best cloud company. All right. So this is the one part of the reconnaissance where you find out the DNS, the certificate of the websites. Gives you the certificate ID, the identities, all the subdomains available for this domain, and then the DNS information, the CNAMEs. Alright, moving back. We can do the same with the command line ns lookup and then bestcloudcompany.org. Again, if you're not very familiar with these commands over here, I would recommend you go to this room, DNS Reconnaissance. It is very helpful and important to master just your reconnaissance skill. Okay, ns lookup is going to provide you information about the provided domain. In this case, is bestcloudcompany.org. Okay, we got the IP address of 44.203.62.152. Okay, now let's do ns lookup this IP address .203.62.152. Okay, so by doing this, we can see that okay, there's an EC2 instance of the AWS service. It looks like the best cloud company is hosted at this IP address. From here, we're able to see that a IP address resolved to EC2 instance based on the non-authority DNS response. Performing a similar check for access that you should see something similar to the following response. Okay, so let's try this one. ns lookup assets bestcloudcompany.org. Okay, and we have these IP addresses. We have 18. We can do ns lookup 18.66.171.86. We can see that it's using the CloudFront service right here. And then let's try the other IP address, 1721.7. Okay, also another CloudFront. So it looks like this CloudFront is using the load balancer. I'm not sure, this is just my guess. But overall, it's using the CloudFront as a service to distribute the content. Okay, it looks like the access.bestcloudcompany.org is hosted by CloudFront. When we go to access.bestcloudcompany.org in our browser on the attack box, there is an interesting message on the screen. There's a note on reference this bucket. Could that be an S3 bucket? So now we can actually go to the website and see what it is. Asset.bestcloudcompany.org. Okay, public S3 buckets naming conventions. One of the first and primary cases for S3 was to host static content for public websites. Until 2018, a newly created S3 bucket would be publicly available on the internet by default. This means that AWS provides a URL that is publicly accessible with the contents of each bucket. The naming conventions for such S3 buckets continue to this day and follow the best format. S3 Amazon bucket key for bucket created in the US East. S3 Amazon. So these are the formats of the S3 buckets URL. Okay. Companies were also commonly known as specific naming conventions for S3 buckets. For instance, access.domainname.com.s3 Amazon AWS.com, or the organization name production.s3. Okay. So what it means that let's check best cloud company in this case. The naming convention, from this naming convention we can actually take a guess of the S3 bucket's name is access the best cloud best cloud company, either with .org or without .org should be fine. Okay, S3 Amazon AWS.com, or the other naming convention is best cloud company dash production and then S3 and then Amazon. Usually, most organizations and companies have these naming conventions for the buckets. Okay, let's go back to the website and see what the message. This is where we'll store site images, etc. to speed up page loading. Once Adam integrates the bucket in WordPress hosting configurations. So here we have several information. First of all, we know an employee named Adam. We know that this bucket, meaning that it's using AWS S3 and the WordPress hosting configurations. So we know that this website or this specific page will be using S3 buckets as an AWS service to store all the site images and then all the files to host, and then the platform to host the website is WordPress. We can use this kind of information for to exploit some vulnerability later. So this is why reconnaissance is important. Alright, so now that all the buckets are public, customers may choose to restrict access to authenticate user or specific IAM principles. But if a bucket is public, you can easily identify the bucket using basic reconnaissance techniques. Public S3 buckets search engines. We have identified target organizations that we are attempting to infiltrate. Best cloud company, and we have identified the primary website. This one. Now it's time to attempt subdomain enumeration to identify potential target for attack. Again, this link to another reconnaissance technique, subdomain enumeration. This is easy, beginner friendly, so I would recommend you take it to know that when you perform a pen test and when you get to know what you should do to get to know your target, what techniques you should be doing. Okay, attack bot. The attacking virtual machine is disconnecting again. I don't know why, but let's just continue. We have identified, okay, search engine. Now that we have found the bucket, Aren't you curious if they are hosting anything else interesting in this bucket? Well, though the bucket isn't large enough, it could have a few thousand objects. How are we going to sort through them all in case this was an incident? Uh, no, through them all in case this was an accident and is quickly found. This is where you will want to take advantage of the AWS command. We will explore in the next task. Because search engines, including Google's, index the S3 Amazon AWS.com subdomain, we can attempt to find public S3 buckets related to the best cloud company organization using the following search syntax in Google. Okay, let's try this. I don't see anything. Often, this is one of the easiest ways to validate the targets associated with any particular organization. Unfortunately, it doesn't look like Google has any index of any S3 bucket for the best cloud company, or should have told me earlier, but okay. So this is going to be the syntax. So if you're performing a pen test on a company, let's say Tesla, then this should be the Tesla. Or if you perform a pen test on Apple, it should be Apple, and etc. So web page source inspection. What in the world is going on? Terminate and start again. Viewing the source for a web page, you may also find S3 buckets or other hosting services embedded as a source for images and other static content hosted on the page. Even further, there are JavaScript scripts embedded and referenced in the page source that indicate other external resources for the page. Through these mechanisms, you may often find access to additional resources that may not be intended for public access. You can use tools like Link Finder, JSA, or subs to automate those on this analysis. DNS Recon. It looks like our target organization is hosting us as best cloud company on S3 buckets, but what's the name of that bucket? Why don't we try access Amazon and see the example? Okay, now because we know the company's domain name, we know its subdomain, and we also know the naming convention right here. We can actually try to perform an NS lookup to this one right here to see if we have any results. And as is shown in this image right here, it shows that this bucket exists. assets.bestcloudcompany.org.s3 Amazon AWS.com. It also have the canonical names right here. Now that we've found the bucket, aren't you curious if they're hosting anything else in this bucket? Well, though the bucket isn't that large, it could have a few thousand objects. How are we going to sort through them in case there was an accident and quickly found? This is where you will want to find. Okay, this is where you want to find many organizations use S3 bucket to host websites, public content, documents, files for the websites. Many of these organizations also host sensitive information in S3 buckets. Sometimes a bucket is left unpublic accidentally. Using above technique, you can still find information for such buckets today. What are two primary methods of identifying public buckets? NS lookup and I'm not sure what the question is about. But let's go. NS lookup assets best cloud company S3 Amazon AWS.com. Ooh, okay. What subdomain do we identify by searching sub? This one? Wait, what? Okay. What are the two primary methods of identifying public S3 buckets? Search engine indexing. Okay, no. Search engine indexing and DNS recon. What was that? Okay. I mean, I don't know why they didn't include the web page source inspection. Maybe because like a lot of times you may not find any helpful results. But anyway, moving on. Okay, lab. S3 abusing the substrates. EC2 and S3 are a common pair of key services. EC2 is an AWS virtual server offering one of AWS most widely used services. While this room is not geared toward teaching you EC2, EC2 is still going to play an important role in this lab. You see that the .bin file that you just found in the weird file name, right? It turns out that this is an EC2 virtual machine image, known as the Amazon machine image. While most organizations will restrict access and deploy purpose-built S3 buckets to store AMIs, Best Cloud Company has decided to store a backup image in the same bucket that hosts the website. I mean, why not? It is the same image used to host the non-static resources associated with the company's WordPress site. Pilfering the image. Before starting your pilfering adventure, we configure the AWS CLI using the AWS configure command in the attack box. We'll specify AWS access key and AWS secret key credential available by clicking the orange cloud details upon the room and specify the default region as a US East one. So what it means is over here in the room, you'll be provided with the cloud credentials. Over here, make sure that the environment for this room is generated. Then you click on this credential tab. You'll be given your credentials to access the AWS account. Now, because I was having some issues with my attack box virtual machines, so I decided to do it on my local machines. And the way to configure that is the same thing, but the only difference is instead of doing AWS configure as instructed right here, I just gonna be adding a name of the profile. So AWS configure, and then with the profile flag right here, and then just whatever name you feel comfortable. In this case, I use the try.me right here. So why do I need to do this? Because on my local machines, I may have different projects on AWS, and depending on the project scope, then I may have different credentials. So for each of those credentials that I set, I have to set up or configure different AWS profiles for those projects, which is why. So in this case, I'm working on try.me's AWS learning path. I named the profile as try.me right here. And then once you enter your access key and secret access key, you can actually run any commands as instructed right here. The other thing is like the other difference that you should notice is because you have many profiles on your local machine, you have to specify the command and the prompt, or you have to specify which profile you want to run with the specific command. In this case, you can see that I run the same command right here, but at the end of the command, I just append the profile name, which is the try.me I've created earlier. And after running the command, you see the image, a new image AMI has been generated. We're going to save this one right here. This command generates new Amazon machine image or AMI from the binary file we found in the S3 buckets. So this is the one we just dumped from the access.bestcloudcompany.org S3 buckets, and then we use this one to recreate an Amazon machine image. Okay, an AMI is another form of virtual machine image similar to OVF, Open Virtualizations Format, or VMDK, Virtual Machine Disk File. These are the files used on VirtualBox and VMwares. Once we have the newly generated AMI ID, we can recreate the workload and see what load we've collected. Okay, the next command is AWS EC2 create key pair. Okay, and then key name is going to be, let's make it lab 3 S3 substrate. Let's make it this way too, and then create key material output text, and then SSH S3 substrate dot pem. Okay, we have to specify the profile that we're using, which is try.me. And this command will create a key pair for the EC2 instance that we're about to create. Okay, now we have the key pair, we have the AMI, which is the Amazon machine image. Now we can go ahead and actually, no, not yet. Next, we will need to find the relevant subnet where we can deploy the instance machine, which we can use AWS EC2 describe subnets file try.me, and we have about the following information. You can use any subnet that has a tag value of subnet A. Next, we're going to launch the EC2 instance from the restore AMI. Okay, where's the tags? Nope, not okay. Yeah, this text is okay. This one is okay. Subtext subnet A is okay. Okay, let's use this one. I'm going to copy this one. Paste it here. Not sure which one I'm gonna be using, but just gonna save it first. You can use any subnet that has a tag value of subnet A. Next, we're going to launch an EC2 instance from the restore AMI. To do that, we'll need to use a security group that allows SSH access. In order for us to be able to SSH into the image we found, you will now have to correct security group, because the description field will allow SSH access for the try.me S3 room. So the next step is to find the security group AWS EC2, describe security groups, again profile track, and we're looking for the one with the allow SSH access right here. This one, the very first one. Description: allow SSH access for TriacMe S3 group. Okay, I'm going to be assuming that we will be using this one, the security group ID. This one, the subnet ID, I would suspect we're using this one. Subnet ID. Okay, what else do we have? Image ID. We need this one. Equals. Okay. What else do we need? Okay, let's look at the command. AWS EC2 Reconnaissance. The image ID is inside the key name, which is the S3 substrate. Subnet ID, security group ID. Okay, let's get started. Let's try it out. So AWS EC2 run instances. Image ID equals to this one. Nope. Yeah, make sure when you copy and paste these values, there's no trailing space. Instance type T3A micro key name. Remember we created that as S3 substrate. Subnet ID is going to be this one. And security group ID is going to be this one. And remember to append your profile name if you're on your local machine, like I do right here. Alright, so now we have the command ready. Let's try that. Paste, and we should be able to create a EC2 instance. Cool. Look, I guess. So now we have successfully created an instance, an EC2 instance based on the restored image that we got from the Best Cloud Company buckets. Now what we're going to do is look for the EC2 instance ID. Right here. The instance ID is right here. Oh no, we need to look for the IP address. My bad. Key name right here. Private IP address. What's the public one? These are all private. You know what? We can actually try this command. EC AWS EC2 describe instances and then provide tracking. Okay, then the key name substrate is right here. Placement. There we go. Public IP address. This one. Okay, and the command, now we have to SSH into the machine. SSH.I, and then it's going to be our key, which is SSH. S3 substrate .pem root add, and then the IP address right here. Is that the correct direction? Yeah, it is. Yes. Please log in as a Bitman rather than user root. Once logged into the instance, you can look around for interesting information. Notice that anything interesting, it turns out the image includes username and password for a default user. How may we use it? Okay, Bitnami. Okay, I'm it. Who am I? LS. Stop. Oh, we have Bitnami credential. Bitnami credential. Welcome to the WordPress packet by Bitnami. User, default user, password. Okay, cool. What service uses Amazon machine images and often used as S3 and often uses S3 as storage for the images? AMI? No. What service uses Amazon images and often uses S3 as storage for the images? EC2, my bad. What is the username for the default password user? Right here. What is the password for the default WordPress user on the AMI? Copy, paste. What is the flag in the WordPress profile of the user? Now, because we know the company, okay, best cloud company as cloud company.org. Let's go here. Yeah. And then we know that is using WordPress, so we can try the admin right here, user, and then password is going to be this one. Copy, paste. Okay, where's the flag? Looking for the flag. Is this a flag? Well done, guys. Boom. Yes. And that's how we leverage an AMI image from Amazon to create a new EC2 instance and try to look whatever and try to exploit whatever vulnerabilities on their target machine. Again, it's not recommended to store your AMI in your S3 buckets because it's dangerous. once the attackers can get into your bucket, then they can actually recreate the image, and they can find any other information to leverage. Even though sometimes they can't escalate the privilege in the machine, they can find valuable information about the users, the system, and etc. And they can use them as the leverage for further exploits. Okay. Summary. S3 summary. S3 is a critical service for AWS customers, and as you see, compromising S3 can have a devastating consequences. During this room, you've learned about the key concepts and terms associated with S3, surveying common security weaknesses associated with the use of S3. We gained an understanding of how attackers may use S3, culminating in our own abuse of S3 and compromise of WordPress database credential. So that's it for the room today. I hope you learned how to attack and defend AWS S3 buckets. Again, this is a pretty long room, and there are plenty of attacks techniques that we have to go over, and I know it's a little bit confusing and that may be overwhelming at first for a lot of you guys. So I would recommend you, after finish this room, retry this room again and again and again for several times until you actually get familiar with the techniques, the defense strategies, and as well as the command lines. Remember, repetitions is very helpful because it helps you remember the concepts and get familiar with that. And thank you very much for watching. I'll see you next time then. Bye.